The main challenges of the recruit maneuver is, first of all, how to apply all the knowledge from the critical care area inside the operating room in order to how we do know what patient can have benefits from recruit maneuvers. Second, when do we have to do it inside the operating room? And the most important question will be how to do it in a safely way.
For us at Dräger, it's very important to support the daily work of the anesthesiologists, also with regards to lung recruitment. And the Primus product family, besides of the ventilation technology, we offer additional monitoring functions. First of all, there is the loop display, where you can see the pressure volume loop and flow volume loops and compare the current ventilation with reference. And very new, we offer additional parameters in trend display, minute volume CO2, oxygen consumption, and the combination of dynamic patient compliance with PEEP. You can see that in the total trend display, but also in 15 minutes mini trend directly on screen. With these functionalities, we believe we bring transparency into ventilation and lung recruitment.
In my opinion, the most important part is how do we know what patient can obtain benefit from these recruit maneuvers. And for sure, the answer is the respiratory monitoring. We must focus on the dynamic compliance of the patient, the trends, and the PV loops, and we will see what patient can be benefit from that. After that, nowadays we have enough background to perfectly know how can we do it in a safely way. I must say that neonatal ventilation is by far the most challenging situation for an anesthesiologist. The problem is that the physiology is totally different, and accuracy in this case is absolutely mandatory. Accuracy in the tidal volume you are delivering in these cases is the most important thing, and accuracy in measure flows and pressure should be very, very, very important, because any variation in adults, it doesn't have too much problem, clinical problem, but in neonates, it's a clinical problem every time.
In pediatric and neonatal ventilation, the accuracy and precision of ventilation are very important. This has also been considered during the design phase of our anesthesia devices. In Primus and Apollo, we have integrated several aspects that contribute to this. First of all, we have fresh gas decoupling, which means that you have the independency between fresh gas delivery and ventilation. Then we have an electronic ventilator integrated, which gives highest accuracy in tidal volume delivery independent from any flow measurement. We do have, in addition, integrated monitoring, continuous monitoring of flow and pressure, which gives the anesthesiologist at any time the monitoring that is required. And we have integrated gas measurement. So you have directly on screen inspiratory and expiratory values for gases, oxygen and volatile agent, and continuous monitoring of CO2 in a waveform.
I'm a pediatric anesthesiologist with more than 14 years of background, and I must say that each time I have to ventilate a preterm baby or a neonate is a real challenge situation. So to have the opportunity to ventilate those patients with a machine with a high accuracy in measure of flow, pressure, and tidal volume is something that gives you a lot of confidence.
I think the main problem with low-flow anesthesia, if you see it, what other physicians do in other hospitals, is that they are afraid that the oxygen they apply is not enough, and that in the circle system the oxygen concentration drops, and they then have a problem of hypoxia, or that the volatile anesthetics is not enough in the circle system.
We at Dräger understand these worries of the anesthesiologist very well, and for that reason we already look since a while how to make anesthesia, especially in the low flow area, more reliable. So for the Primus and for the Apollo family, we are looking here at especially three aspects. One is the integrated gas monitoring system we have integrated in the Primus, where we can see online the inspired and expired volatile concentration. The second is the integrated breathing system with a piston ventilator, where we also have the breathing bag integrated so that you directly can see online the filling level of the whole breathing system. And the third one is an econometer or low flow wizard, where in a very special and very easy to understand bar graph display, the anesthesiologist can see whether the fresh gas flow compared to the fresh gas consumption is in a certain relationship, whether it is too much, whether it is in the right level, or whether it is too low, so that the anesthesiologist has a direct feedback whether the patient will become in a hypoxic situation or not.
I think there are 4 good reasons to perform a low-flow anesthesia in patients during anesthesia. The first reason is patient comfort, and you have a better climatization of the inspired gases. The second reason are ecological reasons. You have a save of the ozone layer destroying gases. And the third reason is economical reasons. You can save up to 90% of the volatile anesthetics, and you have a very good teaching tool to teach physicians the oxygen uptake and pharmacokinetics and pharmacodynamics of volatile anesthetics.